Hello students, welcome to my new video. Now in the previous video I have told you what is the basic concept of a potentiometer, what are the uses of potentiometer, and also I told you in that video how to measure the EMF of a cell using a potentiometer. Today we are going to discuss about two more uses of potentiometer. Okay, so what are those two uses? Number one, potentiometer is used to compare the EMF of two cells. Okay, so potentiometer is used to compare the EMF of two cells, and second, by using a potentiometer we can find the internal resistance of a cell. Okay, so these are the two uses which we are going to discuss today. If those who have not seen the previous video, please check out the previous video where I have in details I have explained what is the concept of a potentiometer and what is the basic use of a potentiometer. So for those who have not seen the video, for them I am telling, potentiometer is a device by which we can measure the potential difference between 2 points in a circuit. Okay, so potentiometer is a very simple device. We have a cell over here or a battery over here. We have a switch. These are the two terminals, point A and point B. And this is the wire. So this is a very simple potentiometer. And in this wire we can measure the potential difference. Okay. So this, suppose the length of this wire is L. L is the length of this wire. And this is a wire of uniform area of cross section. Okay, the area of cross section is uniform throughout the wire. Fine. And this wire, the potential drop in this wire is also uniform. So suppose this battery is of 50 volt. So suppose this is 50 volt, this is 0 volt. So this terminal also is 50 volt and this terminal is 0 volt. Okay, that means if we go from point A to point B, there is a continuous drop in potential. Okay, there is a continuous drop in potential. So see, in length L, suppose the potential difference is V volt. Suppose V volt or 50 volt. In length L, if the potential difference is V volt, then we can say in unit length the potential difference will be V by L. Okay, in unit length, that means in 1 centimeter length, the potential difference is going to be V by L. Now, if I want to find out the potential difference between A and C, this is one more point. Okay, C is at a distance of X centimeter, suppose. So in unit length, the potential difference is V by L. So in X length, the potential difference will be V by L into X. So this is the basic concept of a potentiometer. So we can get the potential difference between A and C. Okay, so VA minus VC will be V by L into X. Now this V by L is constant. As I told in that video also, this V by L is constant, okay, because the potential drops at a constant rate in this particular wire. So this is known as the potential gradient or the potential difference per unit length. So this can be written with K. So Kx. So this will be the potential difference at this particular length. If you want to find out the potential difference at any other length, just you have to measure the length. Okay, you just have to measure the length and the value of K you have to know. That means in this much length, how much potential is dropping. Okay, this was the basic concept of potentiometer. For details, please check my previous video. You will be getting a very thorough description of the concept of potentiometer. Also, I have discussed in that video how to find out the EMF of a cell using a potentiometer. Okay, so today we are going to first discuss about this topic. By using a potentiometer, how you can compare the EMF of two cells. Suppose I have given you two cells, okay, and you need to compare the EMF. Compare means just find out the ratio of the EMF of two cells. Okay, now if you want to find out the EMF of a single cell, that one already we have discussed in the previous video. Over here we are going to discuss how to compare the EMF. Also, one more thing, I told you that this potentiometer, this wire is actually very long. Okay, very long. Now in practical, in reality, when you are going to do the experiments in practical, in lab, so using such a long wire is very difficult. Okay, it's very difficult to carry such a long wire from one place to another and to set up the instrument. So that is why we use a concept of folded wire. Okay, we use the concept of folded wire. That means in that video, in the previous video also I told, this wire is basically folded like this. These are metallic plates. These are metallic plates. Okay, so this wire is generally folded into 4 to 5 parts, and each of this part is 100 centimeter long. So effectively we are getting 400 centimeters of length. Okay, effectively 100 into 4, effectively you are getting 400 centimeters of length, and in the rest of the portion you can connect the rest of the circuit. So instead of using a 400 centimeter long single wire, we use this concept of folded wire. It becomes easy for us to use. Okay, so in this diagram, first I am going to show you the circuit. Okay, so when I will be showing you the circuit, I am going to show you in this way what the actual circuit looks like. Fine. Okay, so let's draw the circuit. So this is the circuit. Okay, now this circuit might look little bit complicated to you, a bit different than the conventional potentiometer diagram which I had shown you, but let me explain this to you very clearly. You see, this is the primary circuit. As I told you, the wire we keep it in a form of, in a folded form. Each of this length generally it is 100 centimeter long, connected by metallic strips. So effectively we get 400 centimeters of length. Okay, so instead of using a very long wire, we use this folded form of the wire. It becomes easier for us. Okay, our main task is to find out the null point. Okay, and see the distance from the point A. Remember, we are going to see the distance from the point A. Okay, so here we have a battery, suppose B1, suppose the battery is B. Here we have a key K1. Over here we have a rheostat. Over here we have a rheostat. Fine. Now, if you have not seen my previous video, over there I explained clearly how to find out the EMF of a single cell. Suppose this is your potentiometer. The rheostat I am not connecting now to make the things simple. So this is point A, this is point B. This is the wire of the potentiometer. Okay, this one is the wire of the potentiometer, and over here we connected the cell. Over here we connected the galvanometer, and this was the jockey. Okay, and we wanted to find out the EMF of this cell. Okay, so our task was very simple. Our task was to move the jockey in the wire AB and find out the null point. Null point means the galvanometer will give you 0 amp current. So 0 ampere current. That means the galvanometer will give you 0 reading. Okay, that means no current is flowing through this particular branch. And I explained over there that when will this condition occur? When will no current flow through this wire? When the potential difference between these 2 points. Okay, the potential difference between these 2 points will be equal to the potential difference between these 2 points. That time no current is going to flow through this branch, because current only flows where there is a potential difference. If there is no potential difference, then no current is going to flow through 2 points. So if the potential difference between these 2 points and the potential difference between these 2 points, if they are same, then no current is going to flow. Now, by the concept of potentiometer, we know that the potential difference between A and J, okay, potential difference between A and J, suppose the length of the potentiometer is L, and suppose this is V volt, this is 0 volt, this is V volt, this is 0 volt, so this is also V volt. Okay, so if that means in length L the potential drops by V, in length L the potential drops by V, so our potential gradient was V by L. And in this particular length, suppose at a distance x you are getting the null point. Suppose at a distance x you are getting the null point. So at this particular distance, that means between points A and J, what will be the potential difference? Suppose V dash will be equals to V by L into x. Okay, so this was the concept of potentiometer. Fine. That means the potential difference between A and J is going to be V by L into x, that is Kx. And we know that current is not going to flow through this branch if the potential difference between these 2 points is equal to the potential difference between these 2 points. Now you see, the potential difference between these 2 points is already E, because the EMF of the cell is E, which we don't know. So when no current is flowing and the potential difference between these 2 points is Kx, so we can very surely say that the potential difference between these 2 points is also Kx. Okay, then only if the potential difference between these 2 points and these 2 points is same, then only no current is going to flow. So if the potential difference between these 2 points is kx, then we can surely say that the potential difference between these 2 points is also kx. So therefore we can say E equals to kx. Okay, because you know the potential difference between these 2 points is E. Okay, because the EMF of the cell is E. So this was how we can calculate the EMF of a cell. Please check out my last video for all the detailed explanation. Okay, over here you see this circuit and this circuit, they are same. Okay, just instead of this straight wire I have used it a folded wire. Okay, and over here there is a scale also fixed so that you can see the length. Okay, how much length, at what length you are getting the null point. The only difference is instead of a single wire, you see from point A only I have connected. From point A only, I told you that the positive terminal of the battery must be connected with the positive terminal of the cell. This one has to be maintained. Okay. So sorry, there is a slight mistake. The positive should be connected with the positive of the battery. Okay. So remember, this thing is very important. The positive should be connected with the positive terminal of the battery. Right. So this thing should be maintained. Okay. So I have corrected this one. The positive terminal should be connected with the positive terminal of the battery. Okay, this one's positive should be connected with this one's positive, or else the potentiometer is not going to work. Now the only difference over here is, you see, instead of a single cell, I have connected 2 cells and they are connected by 2 different switches. Okay, there are 2 different keys, right? And just we have to find out, we have to compare the EMF. Compare the EMF means we just have to find out E1 by E2. Okay. So how to find out? The task is very simple, you see. At first what you will do, this key should be on. Okay, so if this key is on, current is going to flow through this branch. So current is going to flow through the main circuit. So through the main circuit, current is going to flow, right? Over here I have connected the galvanometer and here is the jockey. So jockey, you have to search in, with the jockey you have to search in all the 4 wires for the null point, and easily you can measure the distance with the help of this scale. So 2 different cells are there connected with 2 different keys. At first what I will do, I will keep the key K3 off. Okay, so at first K1 is on and K3 is off. K3 is off. So only this EMF E, that means a cell with EMF E1 is included in the circuit. So if there is one cell, the circuit is becoming like this, the simple one. Okay. Now our task is to find out the null point. Find the null point. Find the null point. Okay. Our task is to just find out the null point. Suppose the null point we are getting at a distance x. Suppose we are getting at a distance x. Okay. Or suppose L1. Suppose we are getting at a distance L1. So by this concept of potentiometer, we can easily say that the EMF of the cell will be equals to K into L1. Okay, because only one cell is included in the circuit, and we know that whatever is the potential difference between these 2 points, that only will be the potential difference between these 2 points. That means that only will be the EMF of the cell. So the potential difference between these 2 points, suppose we are getting the null point at a distance x. Okay, suppose we are getting the null point distance x or at a distance L1. So if you are getting the null point at a distance L1, so suppose this is L1. So what will be the potential difference between these 2 points? K into L1. Okay, yes or no? If you are getting the null point distance L1 from A, okay, always use this particular theory, that always measure the distance from A. You don't do like this, that one time you are measuring from A, one time you are measuring from B. No, not like that. Always measure the distance from this particular point A. Suppose you are getting the null point at a distance L1 from A. So we can say that the potential difference between these 2 points is K into L1 by this concept. Okay. So whatever is the potential difference between these 2 points, that only will be the EMF of the cell. Over here only I have explained. Okay. So EMF of the cell E1 will be equals to K into L1. Fine. This is your equation 1. In the second case, keep K3 on and K2 off. Okay. This one is on. So K1 is on and K2 is off. So if you are connecting this particular key, if you are switching on this particular key, so this cell is in use and no current is flowing through this branch. Okay, no current is flowing through this branch. Fine. Now your task is again you find out the null point. Okay, again you find out the null point. Suppose at the first time, at the first instance, suppose you were getting the null point over here. This was suppose distance L1. Okay. In the second case, suppose you are getting a null point over here. You are getting the null point over here. This is suppose at a distance L2. This is suppose at a distance L2. At a distance L2, you obviously, if both the cells are of different EMF, okay, if both the cells are of different EMF, that means they are of different potential difference. So different potential difference means you will not get the null point at a single point. You will not get the null point at the same place two times. Okay, you will get null point at different points. So first time suppose you are getting here, second time you are getting here, you can get down also, no problem. Just measure the distance with the help of this scale. Okay, so null point means no current is flowing. Null point means no current is flowing. Galvanometer is giving you zero deflection. Again, same concept we are going to use. Okay, that means if you are getting null point at a distance of L2, okay, if you are getting null point at distance of L2, so what is the potential difference between these 2 points? The potential difference between these 2 points will be K into L2. Okay, if you are getting the null point at a distance L2, potential difference will be K into L2. Fine. So that only will be the EMF of the second cell. Because you know, potential, if then only galvanometer will show you zero deflection only if the potential difference between these 2 points is equal to the EMF of the cell. Now this one is switched off, so this one is out of the question. We are only taking this one over here now. Okay, so potential difference between these 2 points is equal to the EMF of the cell. Then only the galvanometer is going to show you zero deflection. That is, no current is flowing through this branch. This total branch, no current is flowing. Okay, so E2 will be K into L. So these are your both equations. Now just do E1 by E2. You will get L1 by L2. Okay. Suppose L1 you are getting at 10 cm, L2 you are getting at 50 cm. So just you divide the distances. 10 by 50, 1 by 5. That will be the ratio of the EMFs. Okay. So this is how you can compare the EMF of the two cells. Next we are going to discuss how to find out the internal resistance of a cell. For that, let me show you the circuit first. Okay, so this is the circuit for how to determine the internal resistance of the cell. You see, the primary circuit is the same, exactly the same. Over here we have connected the battery. Suppose this is B, this is the rheostat, this is one key, our main switch, okay, that is key K1, and here we have used the folded wire. Fine, this is the galvanometer. Over here you see, last time we had connected only either one cell or two cells, but over here I have connected one cell which has an internal resistance R. In the previous case also the cell had an internal resistance, okay, but since we took out at zero deflection, that means at null point means no current is flowing, and you know, if no current flows through any cell, then the internal resistance has no part in it. Okay, current has to flow in that circuit. So if no current is flowing, internal resistance has no part in it. So that is why over there we have not taken internal resistance. Fine. But this cell actually has an internal resistance. Now this internal resistance we are going to find out. One extra thing we have connected over here is this one. This is basically a resistance box. I hope you know what is a resistance box. Over there you can choose, you know, any resistance you like by taking down different combinations. Okay. So over here we have a resistance box, and this resistance I can choose. Suppose the external resistance is 2 ohm, suppose 2 ohm plug I have taken out, or 3 ohm or 10 ohm. Any resistance you can choose over here. Fine. Okay. So before starting the experiment, first what you have to do? First, eliminate this key. That means this key should be off. This one should be on. Okay. So K1 is on and K2 is off. Okay, so if K2 is off, then this particular branch is at first only it is eliminated. So no need to consider this branch. So this branch is eliminated already. Okay, so just think that this branch. This branch is only there connected with the galvanometer. Fine. So first you have to search the null point. You know how to search the null point. Many times I told how to search the null point. Just you move your jockey in the wire, all over the wire, and to find out the distance you have a scale over here. Okay. Suppose at a distance L1 you are finding the null point. Okay. Suppose this is your L1 and at a distance L1 you can suppose you get the null point. Now you know EMF of this particular cell will be K into L1. Okay, because potential difference. Now this particular, don't think about this branch. Okay, this branch don't think, because the key is already off over here. So this branch is already eliminated. This branch is already out of the question. Only this cell is there. Okay, only this particular cell is there. Now when will the galvanometer show you zero deflection null point? That means no current will flow through this branch. When the potential difference between these 2 points and the potential difference between these 2 points, that they are same. Now we know potential difference between these 2 points is EMF. Okay, EMF of the cell. So EMF of the cell will be K into L1. And in the previous videos I have already told that potential difference between these 2 points will be K into L1. K is the potential difference per unit length. Okay. So we got the EMF of the cell, K into L1. Okay. Now see, now you will take out any resistance you want. Take R of any choice. Okay, take resistance R from resistance box. From the resistance box. Okay, so from the resistance box, take out this resistance R. Fine. Okay, and now connect this key K2. Now once we have connected this key K2, that means this both the branches are connected. Remember this one. Both the branches are connected. Now if you see this particular, this is your secondary circuit. Okay, this is your secondary circuit. Now you see, if only we have a cell of EMF E and R. Okay, just I am drawing it separately so that you can understand. If you have a cell only of EMF E and internal resistance R, then I can say that the potential difference between this point and this point is E. Suppose you have a 12 volt battery. So the potential difference between this point and this point is E. Okay? But once you connect an external resistance over here, suppose I have connected an external resistance over here, that time when if current is flowing through this branch, I cannot say that the potential difference between this point and this point is E. Okay, so that time I have to find out the terminal voltage, the potential difference between two terminals, so this point and this point. Okay, so if current is flowing and if there is an external resistance over here, then we know that if current is flowing through any circuit, then the potential drops. The potential is not will be equal. It will not be equal to the EMF of the cell. It will drop. It will drop a little due to the internal resistance, and that time you are going to get the terminal voltage V. Okay. So when current is flowing, suppose the EMF of the cell is 10 volt. Suppose the EMF of the cell is 10 volt. Now when current will be flowing and if there is a resistance R, there will be a drop in potential. Okay. Now suppose the potential difference between these 2 points is V. So in this case, suppose the potential difference. So once I have connected this key, current is flowing through these two branches as well as this branch. Okay. So through this entire circuit current is flowing. So the primary circuit current was initially flowing, and now through these two branches current is flowing. Now when through these two branches current is flowing, now I cannot say that the potential difference is E. Now I will say that the potential difference is V. Okay, V will be the potential difference. That is the terminal voltage. Right? This one I am marking differently. This is your R. So the potential difference between these 2 points is V. Fine. So this concept first you have to understand, that when I have connected this switch, okay, when I have connected this switch, that time the potential difference between these 2 points is no longer E, because current is flowing through the external resistance as well. So there will be a drop in potential and there is an internal resistance as well. So the potential difference now is going to be V. What is V? V is the terminal voltage. Okay, that is the terminal. potential difference between the 2 points. Okay. So let V equals to terminal voltage. V equals to terminal voltage. Okay. So now what I have done, both the keys are on. K1 is on and K2 is on. So both the keys are on over here now. Okay. Both the keys are on over this key and this key. Both the keys are on over here. Okay. Now our task is again you find out the null point. Once again you find out the null point. Okay. So previously the null point was at L1, right? Now once again you search throughout the entire wire and once again you find out the null point. Suppose your null point is over here. Your null point is over here. So suppose at a distance L2. At a distance L2 your null point is. You get your null point at a distance L2. Okay. Null point means no current is flowing through this branch. Null point means no current is flowing through this branch. Fine. I say if you are getting the null point by the concept of potentiometer, if you are getting the null point, that then the potential difference between these 2 points must be the potential difference across the secondary circuit. Okay. Now we know that the potential difference across the secondary circuit is how much? V. V is the potential difference across the secondary circuit. Already I discussed this one. How much is the potential difference? V. Okay, because now when current is flowing, potential difference now is no longer E. It is no longer E, potential difference now it is V. Okay, that is the terminal voltage or the potential difference between these 2 terminals or these 2 terminals, anything or these 2 terminals. Okay, so now the potential difference between this across this secondary circuit is V. And current will not flow only if potential difference between this one and the potential difference between these 2 points, they are same. Potential difference between these 2 points will be K into L2. So I am getting V equals to K into L2. Okay, that is your equation 2. Okay. Now just what I want you see, E by V will be equals to L1 by L2. So now just your task is to find out the internal resistance. So from these 2 equations we are getting E by V equals to L1 by L2. Okay. Now suppose if E by V equals to L1 by L2, L1 you know how much centimeter, L2 also you know how much centimeter. Okay. Keep this equation as it is, like this. I hope all of you are familiar with this equation. EMF is equal to I into external resistance plus internal resistance. Okay. I hope all of you are familiar with these equations. From here I can write EMF equals to IR plus I into small r. Okay. From here you see I can write IR will be equals to EMF minus I into capital R. Okay. Now EMF minus I into capital R. Okay. Now you see what is I into capital R? What is I into capital R? I into capital R, current into external resistance. Current into external resistance means the terminal voltage between across the resistance R. Okay. Current into the external resistance means the potential difference across this resistance R, which is equal to the terminal voltage. Already I said. So this one I can write as E minus V. Okay. So from here I can write small r equals to E minus V divided by I. Fine. Okay. Now over here this I am doing. Over here I can do a slight adjustment. I can do a slight adjustment, you see. From the numerator I am taking V common. So I will be left with E by V minus 1 I. Okay. Now what is V by I? V by I will be equals to the external resistance. You know, V is the potential difference across this resistance and I is the current flowing through this wire. Okay. What is I? I is the current flowing through this wire, through the secondary circuit. Okay. So this wire, that was I. So V by I, that is equal to the external resistance R, E by V minus 1. Now what is E by V? You already know E by V is L1 by L2. Now see over here, EMF I don't know. I don't know the EMF. Okay. V also suppose I don't know. EMF I don't know. VI also I don't know. So E by V we can replace by L1 by L2. Okay. Because we know the length, at how much length we got the null point. So R equals to R into L1 by L2 minus 1. Okay, so this will be your internal resistance of the cell. Okay, so this is your internal resistance. This is your internal resistance. Fine. Okay. So remember, this is how you can find out the internal resistance of a cell. Okay, and those who have not seen my previous video, please check out my previous video. Over there I have given a detailed explanation of the potentiometer, of the concept of potentiometer, its uses, and this video we have discussed about 2 more uses. Okay, so that was within everything within your syllabus. Okay, I hope you understood. This is how you can find out the internal resistance of a cell, but just by simple calculation. And remember, the concept has to be clear. Do not study anything without learning the concept. Make sure you learn the concept first. Okay, without concept, if you learn, you are going to forget. Okay, it is not going to go inside your head. Okay, so if you have, that was all for today. If you have any questions, please let me know in the comment section below. I hope you like the video. Okay, if you like the video, please like and subscribe. Thank you.